Welcome to the EPEVER Troubleshooting Series video. Today we explain how to troubleshoot the XTRA Series controller. We consider the universality of our products as much as possible when designing them, but due to differences in user environments, device failures are inevitable. These issues include but are not limited to poor contact, improper system configuration, high temperature operation, electromagnetic interference, wrong wiring and operation, etc. Usually the device will return to normal after the source of the issues is resolved. But if the device still does not work properly after troubleshooting the above issues, it generally means that there is a fault in the internal components of the controller. This is an XTRA controller and a battery. After connected them, it was found that the controller's LCD screen and LED did not light up. Confirming that the battery is in normal condition, the positive and negative terminals are connected correctly, and there is no bad contact, it can be determined that the internal components of the controller are faulty. How to locate the fault? This is the focus of this video. Let's start testing it. These are the tools we need to use before testing the internal components of the controller, including screwdriver, utility knife, multimeter, extra controller. First, we need to remove the 4 screws on the back of the controller and open the case. Notes: to avoid the risk of electric shock, disconnect the device for more than 15 minutes before disassembling it. Open the case. We see there is no visible damage to the internal components of the controller, and the screen connection wires are solid. Therefore, we should conduct more in-depth testing. For easy detection, disconnected the display cable. Take care not to damage the display cable connector when removing it. Usually, a controller, there are 7 main components that need to be tested: fuse, lightning protection tube, battery anti-reverse MOSFETs, solar panel anti-reverse MOSFETs, charging MOSFETs, discharge MOSFETs, capacitors around the microcontroller unit. The fuse, lightning protection tube, and microcontroller unit capacitor require resistance test, while the other components need diode voltage drop test. The range of their respective values is shown in the figure. With this measurement guide, we only need to measure one by one according to it. The measured value outside the range can be judged as a fault point. Next, we will show you the specific steps of measurement. For other different series of controllers, you only need to measure in the same way. Measure the resistance of the fuse. Turn on the multimeter and adjust it to the ohm range. Then use a knife to gently scrape off the 3-proof paint on the exposed part of the fuse. This step is very important. To avoid component oxidation, PCB board is painted with 3-proof paint before leaving the factory, so we need to wipe them off before measuring. Test it with a multimeter. We can see that the fuse resistance is 0 ohms. This value is within the normal range, indicating that the controller's fuse is not damaged. Measuring the lightning protection tube. Use the same method to scrape off the 3-proof paint, connect the multimeter, and measure the resistance to be much greater than 1 kilo ohm, and the lightning protection tube is not damaged. Now measure a group of MOSFETs. The measurement method for MOSFETs is the same. We will use the charging MOSFETs and battery anti-reverse MOSFETs as examples to demonstrate the detailed measurement procedure. Before starting the measurement, we need to know a little about the MOSFET's pins determination method. Common MOSFETs have 8-pin patches and 3-pin patches. The correct way to determination is that let the MOSFETs face you. The 8-pin MOSFETs has pins 1 to 3 as S poles, pin 4 as G poles, and pins 5 to 8 as D poles. The 3-pin MOSFETs from left to right are left G pole, middle D pole, right S pole. When testing, be sure to use the diode range of the multimeter for measurement and connect the red pen to the S pole and the black pen to the D pole. Below, we will demonstrate the specific measurement method. Set the multimeter to the diode gear. Scrape off the 3-proof paint. Because the battery anti-reverse MOSFETs of our extra controller uses a 3-pin patch, according to the previous method, we know that its pins from top to bottom are G-pole, D-pole, and S-pole. If the device you are using does not match the video, please be sure to refer to the previous judgment method to determine the pins before measuring. Let's measure it. We see its voltage difference is 0.48 volts, indicating that the battery anti-reverse MOSFETs is working properly. As for the charging MOSFETs, since it is installed on the back of the circuit board, so if you have time, you can continue to disassemble the circuit board, and then you will see all the MOSFETs. You can determine the pins according to the previous method, and then measure them. Measure it. We can see that the charging MOSFETs can also work normally. As for the remaining 2 groups of MOSFETs, users can measure them by themselves. So far, the components we measured seem to be fine. Next, we measure the resistance of the capacitor's microcontroller unit capacitor. Finding the microcontroller, there are 2 sets of capacitors around it, C55 and C56. C59 and C60. Since these 2 sets of capacitors are very small, so be careful when scraping off the 3-proof paint with a knife. Measure it. The resistance value is 3 ohm. According to the reference range of resistance values given above, we can be sure that this is the fault point. Continue to measure the remaining capacitors. The results are the same. Now we can determine that the controller not working because of the auxiliary power supply of the microcontroller unit damaged. There are many reasons for damage to the auxiliary power supply of the microcontroller unit, including static electricity, open circuit voltage of solar panel exceeds the maximum limit, long-term high temperature operation, etc. When the controller is considered to be in this situation, you do not need to make other measurements, and the device must be returned to the factory for processing. Right now, you should contact our after-sales team or local dealers in time. They would be very enthusiastic to help you. Here is our contact information. Remember, for some simple faults, customers can repair them by themselves, but if you feel that you are unable to do it, please leave it to us because we are more professional.